Okay, so we're going to do some do notes on sum and difference identities. So for our 5-4 homework. Okay, so we're doing this lecture in a class. So if someone entered in questions and such, if you're watching this on video, then you can just kind of fast forward if you don't have a question on what we're doing. So on the investment, we're going to work through some of the even questions. So the first one is number 2, and it says to find the cosine of 375 degrees. Okay, so first of all, so we're talking about if you take out if you have your salmon color cardstock formula sheet, then you recognize in the upper left-hand corner it says sum, difference, formulas. Hi, Mr. Yulin.
We live right now?
We're live.
Huge.
Giddy up. What's up?
I just don't know what to do on this thing. I'm just going to sign it and turn it in.
Yeah, but all you have to do is make a check mark right here. No changes. Then sign it.
But that's all right.
All right. All right. Okay, so first of all, we want to know why. Like, why are we doing this? Okay? Because really what the instructions say here are to find the exact values for the cosine of 375 degrees. So my first thought would be, well, okay, 375 degrees, what reference angle does that give me? Giddy up, Mr. Yulin. Yes, we have gone a full circle around the unit circle, and we've gone an additional 15 degrees. Everybody agree? And then we say, well, shnikes, because that's a 15-degree reference angle, and we don't know what to do with a 15-degree reference angle, so we say, hallelujah to the sum and difference formulas. So this is how it goes. And this is the easiest way to do this, okay? If I were you, I would just take my calculator out, okay? And I would plug in 375 degrees, okay? And then I would start subtracting reference angles until my answer also gave me something that was a 30, 45, or 60 degree reference angle. Does that make sense? So if you just plug in 375, subtract 60, what does it give you? What? What's it give you? 315. So I go, ooh, giddy up. So I just said 60, and I shouldn't even put a parenthesis on there. 60, and then you said 315. And I'm saying, whoa, that's cool. Both of those have reference angles, right? Obviously 60 degrees is a reference angle. 315, isn't that a 45-degree reference angle in the fourth quadrant? So I'm like, giddy up, that's going to work. Anybody come up with something else? Did anyone come up with another pair? Okay, well then we're just going to go with this. Okay, so I said I know that using 60 and 315, that the cosine of 60 plus 315 is the same thing as the cosine of 375 degrees, correct? Okay, so I go to my friend the formula sheet. I look for cosine sum, because that's what we're doing. And you'll notice on that formula sheet, I think it's the first one on there, isn't it? And it says the cosine of alpha plus beta equals cosine alpha, cosine beta, minus sine alpha, sine beta. What is alpha? It's just whatever the first angle is. What is beta? It's just whatever the second angle is. So really all I do right now is I just plug it in, plug it in. So cosine sum is going to be cosine 60, cosine 315, minus the sine of 60 and the sine of 315. Does that make sense to every single one among you? Okay? So again, we just started with 375 degrees, plugged it on our calculator, and started subtracting 30, 45, or 60 degree reference angles till we found one that gave us an answer that was also a 30, 45, or 60 degree reference angle. Okay, we're going to get more practice with that on later examples. All right, so I don't need to Widmopoy cosine of 60 degrees because I know that the cosine of 60 degrees is just the x coordinate at a 60-degree reference angle, which is 1/2. I was kind of hoping for a beautiful choral response, which I did not get. That would have been nice if that was on the video, if they could hear you say that. Okay, and then cosine of 315 degrees, well, golly jeepers, that just gives me a 45-degree reference angle in the fourth quadrant, does it not? Okay, so the cosine would be the x-coordinate, which would just be what, scholars? Radical 2 over 2. Right, Renee? Okay. And then the sine of 60 degrees, which is clearly radical 3 over 2, and the sine of 350 degrees, which is the y-coordinate in the fourth quadrant, which would be negative, right? Negative radical 2 over 2. Does that make sense to every single one among you? Got to know your unit circle. That's not going away. It's just going to come up more and more and more. So we just got to get that done. All right. So if we simplify, that gives us a radical 2 over 4, and that's going to be a plus, isn't it? Negative times a negative. Radical 6 over 4. And then I say giddy up because I have a common denominator. So this is radical 2 plus radical 6, all divided by 4. What have we just found? We found the exact value for the cosine of 375 degrees. Okay, so if you plug that on your calculator, radical 2 plus radical 6, and divided it all by 4, what comes up on your display would be the exact same thing as if you just plugged in 375 degrees. You could check to see if you got it right. That's a good point, Liz. So if you're doing this on a test and you had the time to do it, you could just plug it in and make sure it's the same thing. It's a good point. I've never thought to do that. All right, any questions? Okay, the next one is going to give us an opportunity for you guys to kind of practice this and initially and see how we do. The sine, shnikes. Whoop. Okay, the sine of negative 105 degrees. Okay, so scholars, just plug in 105. Don't worry about the fact that it's negative, okay? And start adding or subtracting things to 105, adding or subtracting things that are reference angles until you get an answer that is something that is also a reference angle. Liz? You mean a coterminal angle? No, I don't think so. Yes, Alondra? What'd you say? 45 and 60. What else? Come on, people. Get your calculators out. I want to get a couple of these so we can see. Yeah, I mean, because really eventually we're just going to manipulate what we want to be positive and what we want to be negative to get. Pardon me? 75, not a reference angle. I think 45 and 150, right? Couldn't I subtract? Wouldn't that 45 minus 150 give me negative 105? Okay. Right? Anyone come up with anything else? Like if we were actively engaged in doing this, we'd come up with 4 or 5 of these. okay? And it doesn't matter. If math works, we should be able to come up with any pair of these, plug it into the formula, have completely different looking questions initially, but in the end get the same answer. If it didn't work, well then we can just all quit, go home, take a nice long nap because math doesn't work. But it does, which is kind of pumps me up about what we're doing. So here we go. So let's say, so if I chose those two numbers, then when I rewrite it, I've got to write it in a way that it's going to give me negative 105. So I would choose to say, well, that's 45 minus 150 would give me negative 105. So is that clear? Does that make sense to everybody? Give me like yay nods or no nods so at least I know that I'm making sense. Yes? So you just need to find numbers that have reference angles. Okay? Doesn't matter. It doesn't matter. So if I use the other one, it would have been the sign of negative 45 minus 60, right? Okay? And when you plug it in, it would give you the same thing. All right, so I go to my formula sheet, I look for sign difference, and it says sine alpha cosine beta minus cosine alpha sine beta. So alpha just means the first term. So the sine of 45, the cosine of 150. Again, this is sine difference, so minus cosine 45 degrees and the sine of 150 degrees. So that's just plugging into the formula. I recognize that this is sine difference, so I go to the sine difference formula and plug it in. Okay? What? Okay. So here we go. Sine of 45 degrees clearly is what, class? Oh, radical 2 over 2. Cosine of 150, well, maybe I'll just Whitmore that just to make sure. That's a 30-degree reference angle in the second quadrant. It is the x-coordinate, which would be what? Negative radical 3 over 2, correct? Cosine, the x is negative in the second quadrant, and the x-coordinate of a 30-degree reference angle, radical 3 over 2. Minus cosine of 45 degrees is radical 2 over 2, and the sine of 150 degrees, so again we're looking over here, that's going to be what? Yeah, positive 1/2, right? Okay? You with us here, Jacob? Okay, you have a pained look on your face, right? Is your headache bugging? That stinks. Okay, so this is going to be negative radical 6 over 4 minus radical 2 over 4, right? So again, common denominator. And you'll notice like these answers, sometimes they look awfully familiar to the ones, and aren't those kind of the same numbers as the first example? But that's it. That's the solution. Yes. Yep. Okay? All right. Look at number 6. Okay? Look at number 6. Just looking at that, doesn't that thing look like really nasty? I guess for the sake of these notes, I should write it out. It is, exactly, Liz. It's just working backwards. So isn't this just a cosine plus sine, which is what? Isn't it cosine difference? Is it cosine difference? Okay. Cosine difference would be that, right? So if you just look at your formula sheet, it was a cosine plus sine, which is just cosine difference, okay? Where this was alpha and this was beta, okay? So that's just the cosine of 120. And 120 is just a 60-degree reference angle in the second quadrant. So the x would be what? -1/2. Blam. So these, if they give you these, they look nasty, but they're actually easier. Okay? All right. We have two more of these bad boys that we want to be able to do. Okay? How are we doing on time right now? Shh, Nikes. All right. Okay, number 8. The tangent of 345 degrees. Let's see if we can get through this. Okay, help me out. Find reference angles. Since it's a big number, chances are we're going to be adding 2 reference angles to get that. Ooh. I heard 300. Will the Thrill said 345. I think that looks pretty good, doesn't it? Okay, we have a 60-degree reference angle and a 45-degree reference angle. What am I going to be doing with these? I'm going to add them. So it's the tangent sum. Right? So I just go to my friend the formula sheet. I look for tangent sum, and it says tan alpha plus tan beta. So the tangent of 300 plus the shnikes, plus the tangent of 45, all divided by 1 minus the tangent of 300, tangent of 45. Everybody good with that? Yes? Tangent sum is the sum of the tangents. Oh, thank you. Giddy up. That would have made my entire video wrong. Now it's still spotless at this point. Keep doing that, please. Okay, carry on. Tangent of 300 degrees. I need to Whitmapoi that. I'm just a Whitmapoi kind of guy. Isn't that a 60-degree reference angle in the fourth quadrant? What would the tangent be? It's radical 3, and in the fourth quadrant, positive or negative? Negative. Negative radical 3 plus the tangent of 45 degrees, which is 1. Okay? 1 minus, the beauty here is we've already figured these things out. Tangent of 300 was negative radical 3, and the tangent of 45 was 1. Okay? So now, let's see, I'm going to rewrite this as 1 minus radical 3, and I'm going to call this 1 plus radical 3. Okay, am I finished? No! What's just not right? Yeah, we clearly cannot have a radical in the denominator. That would just be not right. But clearly, can't we just cancel them and say 1? No! Can't do that either, because we cannot cancel cross radicals, right, across addition and subtraction signs. What must we do? Could somebody tell me what the next step is? This is from Algebra 2. Please state the teacher from whom which you represent as you share this answer. Full names, please. Anyone? Emily, who is the Algebra 2 teacher with whom which you represent? Ooh, Miss Mackenzie Wall. What do you do, Emily? 1 plus radical 3? Shenanigans. Okay, you were so close. 1 minus radical 3. I didn't. Okay, so we want to get rid of the radical in the denominator, right? That's our goal. And if we create a difference of two squares, good things will happen. So it's called the conjugate, okay? And you just basically write what you have in the bottom, but you change the sign. Watch the goodness that takes place. Okay, so in the, I'll make parentheses out of this. I got to finish this, people. If I FOIL this, okay, 1, that's going to be negative 2 radical 3 plus 3. If I FOILed that, that's what I'd get. And in the bottom, when I FOIL, I'm going to get 1, then I'm going to get minus radical 3 and a plus radical 3, so they cancel. And the last give me that. And that's why I do it, because all the radicals will be gone. Okay? So this is just going to be 4 minus 2 radical 3 all over negative 2. So that's just going to be negative 2 plus radical 3. Does that make... So negative 2 goes into 4, negative 2 times. Negative and negative is going to make that a positive. Do you see the 2's canceling there? And then negative 2 into this. Negative 2's cancel, and we just have a plus. Yep. So that is, in fact, the SLU. Okay, that's, so you guys got odds from this sheet. And clearly, I think we're going to be able to still, oh, poop! Oh, that's on the video now, too, me saying poop, which is so unprofessional.